So now we start with the organic constituents of urine. First and foremost, we have urea. So for urea, there are two experiments. One, sodium hypobromide test. Hypobromide test. Secondly, specific urease test. We take urine 2 ml and sodium hypobromide solution. Sodium hypobromide solution. 4 to 5 drops. That's it. So, what do we observe? Brisk effervescence. So this brisk effervescence is due to nitrogen gas. Nitrogen gas. So you'll see the bubbles. You have to show the bubbles to the examiner. So this is brisk effervescence of nitrogen gas. So what is happening is when the urea inside the urine sample, so when that urea is treated with sodium hypobromide, that decomposes to give nitrogen. So the inference is obvious that urea is present in normal urine. Now to talk of specific urease test. This is called specific because this test is actually very specific to detect urea. That's why the name, specific urease test. So what we are doing, we are taking urine 5 ml. Now we are taking urease suspension. Urease suspension. And we are adding phenolphthalein. Phenolphthalein. We add 1 to 2 drops of phenolphthalein. We rub it with the hands and leave it for 15 minutes. Some standard textbooks also recommend to use one extra control. Like the main test will have active urea suspension and the control will have inactivated urea suspension. But some colleges don't use the control, they just use one urea suspension. So, this is the procedure, and now what is the inference? The inference will be pink color. Pink color. So, the pink color is observed. And if you are using the control with the inactivated urea suspension, then you will not find a pink color, because the urea suspension is inactive. So here, so why this pink color is coming? Because first of all, this urease will convert urea into ammonia and carbonic acid. Then this ammonia and carbonic acid will be converted to ammonium carbonate, and as the pH of this reaction is very much alkaline, around about 9.5 pH, so phenolphthalein, which is the indicator, will give a pink color. That is the basic principle. So inference will be same, that urea is present in normal urine. And now to the Viva question favorites. What is the normal excretion? Normal excretion, some books say it is 20 to 30, some books say it is 25 to 30. it is best to stick to a standard 20 to 30 grams per day. Note the unit. Some students tend to confuse urine excretion units with serum levels. Do not do that. For urine, they are mostly grams per day or milligrams per day. That is for all the urine excretions. So that is your daily excretion of urea. And this depends on the protein intake. Why? Because urea is the breakdown product of protein catabolism. Okay. So from there we can draw this inference. So as urea excretion is dependent on the protein intake, so it will be increased in high protein diet. High protein diet. And in which conditions will it be decreased? So urea excretion is decreased in one, nephritis, two, liver diseases. So that was about urea. So our next organic constituent of urine which we will discuss is uric acid. So under uric acid there are two tests, phosphotungstic acid reduction test and Skiff's test. Phosphotungstic acid reduction test and Skiff's test. So we start with the procedures. So phosphotungstic acid reduction test, what are we doing? Urine mostly 5 ml, as with most other tests, and we take phosphotungstic acid reagent. We take phosphotungstic acid reagent, few drops, and we take 20% sodium carbonate. 20% sodium carbonate, mind you. 20%. For the ammonia test, it was 2% sodium carbonate, but here for the uric acid phosphotungstic test, it is 20% sodium carbonate. Don't be confused. So the observation, deep blue color. Deep blue color is formed. Why is this formed? Because uric acid has a reducing property. So uric acid will reduce phosphotungstic acid to tungsten blue. Tungsten blue, hence the blue color. And the inference is obvious, uric acid is present in normal urine. Now to talk of Skiff's test. Skiff's test is a bit unique because this is the only test in all these where we are using a filter paper. So what we are doing? Moisten filter paper with ammoniacal silver nitrate. Ammoniacal silver nitrate, and then on the filter paper we add urine. So here we are taking the silver nitrate first and we are adding the urine later. So what is the observation? Black spots are formed on the filter paper. Why? Because uric acid has a reducing property as we discussed some time back. So here uric acid reduces silver nitrate to metallic silver, and this metallic silver is black. That is what comes on the filter paper. So the inference is same, uric acid is present in normal urine. Now to talk of normal excretion and which conditions increased and decreased. So normal excretion of uric acid in the urine is 0.6 to 1 gram per day. 0.6 to 1 gram per day. It might slightly differ in different books, but this is a standard. 0.6 to 1 gram per day. And this will be slightly less in women and slightly less in the elderly people. Slightly reduced in women and elderly. Now, which conditions increased, which conditions decreased? Increased in gout, very important, because gout is related to the purine metabolism, and uric acid is the breakdown product of purine metabolism. This is a very commonly asked either question also. 1. Gout. 2. Lesch-Nyhan syndrome, which is due to the deficiency of the enzyme HGPRTase, hypoxanthine guanine phosphoribosyltransferase transferase deficiency. This is also there. And diet, we should mention about diet. High purine diet. So if we eat meat and all, so those will contain more amount of the purines. So meat, high purine diet. And leukemia. Leukemia, which is one type of blood cancer. So these 4 conditions, your uric acid excretion in the urine is increased. And if we talk of decrease, chronic glomerulonephritis. So in chronic glomerulonephritis, the uric acid excretion in the urine is decreased. So now we'll talk about the next organic constituent of urine, that is creatinine. The name of the test that we do is Jaffe's test, named after Max Jaffe. Maffei's test. So what do we do? What is the experiment? We take urine, 5 ml, we add 1% picric acid. 1% picric acid. And we take sodium hydroxide. 10% sodium hydroxide. 1 to 2 drops. So urine plus picric acid plus 10% sodium hydroxide. What is the observation? Orange color. Orange color is formed. Why is it so? Because the creatinine which is present in this urine sample, that creatinine reacts with this alkaline picric acid to form creatinine picrate. Creatinine picrate. Inference: creatinine is present in the normal urine. Creatinine is present in normal urine. Now to the normal excretion. How much is it? 1 to 2 grams per day. 1 to 2 grams per day is little bit less in women and little bit less in the elderly people. Less in women, less in elderly. Now which conditions increased, which conditions decreased? It's increased in certain conditions like muscular dystrophy and myasthenia gravis. Muscular dystrophy and myasthenia gravis. Decreased in advanced renal failure. So that was about creatinine in the urine. The next organic constituent which we'll be discussing is urobilinogen. So what is the procedure? We take urine, we add Ehrlich's reagent, this is important, Ehrlich's reagent. So we take Ehrlich's reagent, 1 ml, and we let it stand for 5 minutes. Let it stand for 5 minutes. So what is the observation? Red color. Red color is seen when viewed through the mouth of the test tube. So now the next question, why this red color is coming? So it's coming because urobilinogen present in the urine. So this urobilinogen reacts with the para-dimethylaminobenzylaldehyde of the Ehrlich's reagent to give the red color. Urobilinogen reacts with para-dimethylaminobenzylaldehyde which is present in the Ehrlich's reagent to give this red color. Now finally, to the wider question favorites, what is the normal excretion and where it is increased and decreased. Normal excretion is traces, normally it is traces. So if it is more, so if it is increased, that is found in hemolytic jaundice, also known as prehepatic jaundice. And where is it decreased, the excretion? Obstructive jaundice. Obstructive jaundice, also known as post-hepatic jaundice. Here I had to change the line because we are short of space. Sorry for that. Yeah. So urobilinogen is increased in hemolytic jaundice, the excretion. Urobilinogen excretion is increased in hemolytic jaundice and it is decreased in obstructive jaundice. Thank you.